let's go ahead and get started there. So just paper to write on, and then if you can just watch this again, I'll upload this, and if you need to watch it again, or send me an email with a question or something like that, that'd be fine. So yesterday we did that little exploration, which I know some of you have done before, and you've seen Radian Measure before, but we kind of rely on Radian Measure because in the long run it's much more useful. Most of you are going to go on and take 1050, 1060, you're going to take calculus and stuff like that. So you're going to see this stuff again, and you're going to use Radian Measure all the time. So we're going to go back and forth. We're going to use both, but that activity yesterday kind of set the stage for today. We're going to add to that just a little bit as we go through the section and as we look at some of the problems that are assigned. So this first part starts off and it talks about how trigonometry is about the measurement of angles and triangles and stuff like that. And it talks about how trigonometry was originally used just to measure angles and triangles and figure out what sides are and stuff like that. And then once calculus was developed, it was found that there were a lot more uses for trigonometry than just dealing with triangles. In fact, they've got a whole list of things here like sound waves, light rays, planetary orbits, vibrating strings, pendulums. A whole bunch of stuff can be figured out using trigonometry. So we're going to look at this from both perspectives. We're going to look at things from a triangle perspective, and angles on a triangle and figuring out sides of a triangle, but we're also going to look at uses for trigonometric functions, which we'll introduce next week. So this entire section is about angle measure, radian and degree measure. Just some vocabulary here that you need to keep track of. The way we make an angle is we start with two rays. They have that common point of vertex. And we call the side where they start, we call that the initial side, and we call the side where the angle stops, we call that the terminal side. Normally we could put it in something called standard position. That's what this is called right here, standard position. We have the initial side on the positive side of the x-axis, and then we open up the other angle in a counterclockwise fashion. Okay, now there are a couple of good reasons for that. The main one would be if we draw an angle right here in quadrant 1, it would be a positive acute angle. And that keeps us in a nice quadrant that we're a little bit more familiar with maybe than some of the other ones. Okay, so we've talked about initial side, we've talked about terminal side, the vertex. Positive angles are what we get when we rotate counterclockwise, when this terminal side opens up in a counterclockwise fashion. We get negative angles if it opens up in a clockwise fashion. And then there's this word here, coterminal. Okay, so coterminal is a word you've got to be aware of because there are lots of different angles that look very similar, but they have different measurements. Okay, so we're going to say this, and we're going to modify this in just a minute. Coterminal means end in same place. Oops, make that a little. But they have different measure. So they have the same terminal side, they end in the same place, but they've got different measurements. So this picture right here just indicates if we're going from standard position, again, start with the positive side of the x-axis, and if you go in a counterclockwise direction, those would be angles with positive measure. If we go in a clockwise direction, those are angles with a negative measurement. Okay? So we've got this Greek letter here, alpha, and this Greek letter here, beta, and we usually use those Greek letters to represent the measurements of angles. Okay? Kind of differentiates them. You can use capital letters, but we normally use the Greek letters. We'll use those most of the time. Okay? So you'll notice this angle is in standard position. Here's the positive side of the x-axis, and then here's the terminal side. Here's where the angle ends. Well, angle alpha is this one right here, and angle beta is this one right here. So the only difference between the two of those is we've measured alpha in a positive way, and we've measured beta in a negative way. And yet they look exactly the same. So the terminal side ends in the same place. These are coterminal, but they would have different measures. This one would be a little bit more than 180 degrees here if we were doing this in degrees, and this would be a little bit less than 180 degrees there. Okay? Could you tell me anything about alpha and beta if we put them together? Yeah, all together, if we took their absolute values, they'd equal 360 degrees. Okay, so this is negative. If we just took the size of that, stripped the negative off, and took this one right here and put them together they'd be all the way around the circle. Now, that doesn't always happen. Let's take a look at this example right here. On this one right here, here's alpha. Say it's about 45 degrees or something like that. And beta is represented by this angle. Go all the way around in a positive direction and then go just a little bit more so that you end up in the same place. So take that side and start it right here, swing it all the way around the circle plus a little bit. These end in exactly the same place. They're coterminal, okay, but they'd be 360 degrees apart. So for instance, let's say alpha was 40 degrees. If I went all the way around, that's 360 degrees, and then 40 degrees more, beta would be 400 degrees. So those two are coterminal, even though they have different measures, because they end in the same place. That's why we call them coterminal. Both of them end in the same place. Their terminal side coincides. Any questions there? Okay, so that's a bunch of vocabulary that you can see in your textbook. If we go to the next page, it starts talking about radian measure. Radian measure is what we talked about yesterday. So their definition in this textbook is 1 radian is the measure of a central angle, theta, and that's another Greek letter, theta, that intercepts an arc S, so here's the arc, that's exactly equal to 1 radius in length. So there's the radius. If we take that radius and stretch it out here like we did the pipe cleaners, that's what we mean by 1 radian. And then this diagram right here should look really familiar. What they've done is they've taken this, there's a radius, there's another one, and so forth. So you should have had something very similar to this on your circle that we worked with yesterday. Okay? Little bit shy of 3 radians all the way, or for halfway around the circle, and a little bit shy of 6 and some radians to go all the way around. So if we were to write this down, this right here is 6.28 radians as a decimal approximation. What was it if we wrote it down exactly going all the way around? 2 pi, okay? So 2 pi radians all the way around. Pi radians to go halfway, or if we wrote a decimal for that, 3.14. What was 90 degrees in radians? Pi halves, okay? Or about 1.57. And this one was 3 pi halves, and we're going to see these several times, and these are things that you've got to have memorized, okay? Or about 4.75, I think is roughly what that is, okay? All right, now, here's a picture down at the bottom of this page, and I'd like you to take a look at this. And I mentioned this yesterday. I find it easier to think in terms of this. So let's go through this diagram, but let's go backwards. 2 pi is all the way around the circle. Okay, so all the way around the circle would be 2 pi radians. If we do half of the circle, that's going to be pi radians. So the top half of the circle is pi radians. And then just keep slicing that in terms of this top half of the circle. If I do half of the top half, that's going to be pi halves. Okay? Again, compared to the top half of the circle. If I do a third of it, that's pi thirds. This is the same as 180 degrees, so pi thirds would be the same as 60 degrees. Okay? Those are angles that you're going to have to know. They come up all the time. If I cut the top half of the circle into fourths, that's going to be pi fourths for this right here, and a fourth of 180 degrees is 45 degrees. So pi fourths is the same as 45 degrees, and if I take the top half of the circle and I slice it into 6 pieces, 6 equal pieces, this is going to be pi 6, or that's the same as 30 degrees, okay? Those measurements come up all the time, so you really need to know those well, okay? Any questions there? Okay, and then they talk about acute. Acute angles would be between 0 and pi halves, okay? Obtuse angles would be between pi halves and pi, so they'd be more than 90 but less than 180, okay? All right. So if we keep going and we flip the page over, The next page talks about where angles end, and it talks a little bit about coterminal angles. Now, they bolded the coterminal on the first page, but they didn't bold it here, and yet here's where they kind of give their definition of what coterminal is. It says they're coterminal if they have the same initial side and terminal sides. Okay? So, for instance, the angles 0 and 2 pi, those are coterminal. There's 0. If I go all the way around, I end in exactly the same place, so that would be coterminal. The angles pi 6 and 13 pi 6 are coterminal. Okay? So pi 6 and 13 pi 6, those are coterminal. So if you stop and think about why, okay, and sometimes it's helpful to do this. We normally don't write it this way. How many times does 6 go into 13? 2. How many left over? 1 left over, right? So this would be 2 pi plus pi 6. So 13 pi 6 is all the way around the circle plus another pi 6. So this angle not only is 13 pi 6, but it's coterminal with pi 6. Just that little slice right here is just pi 6. Okay? All right. So quadrant 1 are all the angles between 0 and pi halves. Quadrant 2, all the angles between pi halves and pi. So again, we're just going around the circle. Here's 0, here's pi halves, here's pi, here's 3 pi halves, and then there's 2 pi. Okay? So there are each one of the quadrants there. And it talks about how we can get a coterminal angle. So if we take pi 6 and then we add some multiple of 2 pi, okay, this 2n pi, and sometimes books will say 2k pi, as long as that number is an integer, this will produce another coterminal angle. So let's take pi 6 and let's add, pick any integer you want. Probably the easiest integer would be a 1. So if I take pi 6 and I add 2 pi, that's start at pi 6 and then go around the circle again. So start right here and go around the circle again. That's going to give us 13 pi 6. That's why the two of those are coterminal. How could I come up with another positive one that's coterminal with pi 6? I went around the circle once more. That gave me another one that was 13 pi 6. How could I find another one that's coterminal? Go twice. Okay? So that's going to be pi 6 plus. Instead of putting a 1 here, meaning go around one full circle, let's put a 2 there. 2 times around the circle is going to be 4 pi. And if we add that to pi 6, so the hard part about this, the thing that people struggle with for the most part with radians is fractions aren't our favorite, and yet you've got to do fractions to do radians really well. So this is going to be in 6, this would be 24 pi 6. So when I add those together, I get 25 pi 6. So all of these, all of those are coterminal. Okay? Now, is the only thing I could do to make a coterminal angle to go another revolution in the clockwise direction, in the positive direction? No, I could also go in the other direction. So I could take this and I could say, you know what? It can be any integer I want. How about I take pi 6 and I do plus 2 times negative 1 times pi? Or in other words, that's pi 6 minus 2 pi. So start right here, and instead of going in the clockwise direction, let's go in the counterclockwise direction. Sorry, instead of going in the counterclockwise direction, let's go in the clockwise direction. So if I do that, again, adding those together, I've got to figure out what this is as a fraction. This is going to be pi 6 minus 12 pi 6. So that's going to be negative 11 pi 6. So there's another one that's coterminal. All of these highlighted angles in yellow, they're all coterminal. They all end in exactly the same place, but they've got different measurements. Okay? So you can make a coterminal angle by adding 2 pi, or 4 pi, or 6 pi, any multiple of 2 pi. Okay? Or in degrees, we could add 360, or subtract 360, or subtract 720, or 1080. Any multiple of 360 will give us another coterminal angle. Okay? Any questions there? Okay, so that's what they've talked about right here is they're just talking about how to find coterminal angles. You'll notice on this one, they subtracted 2 pi to get back to pi 6. They subtracted 2 pi. That means that this angle right here and this angle right here are coterminal, and let's take a look at why. Here's 3 pi fourths. Oops, make that one look right. There's the top half of the circle divided into fourths. There's 1 pi fourth, 2 pi fourths, and 3 pi fourths. That is coterminal with negative 5 pi fourths, because there's negative pi fourths, negative 2 pi fourths, negative 3 pi fourths, negative 4 pi fourths, and there would be negative 5 pi fourths. Okay? So you can either add or subtract any multiple of 2 pi, okay, any integer multiple of 2 pi, in order to get another coterminal angle. Okay? Here's an angle of 4 pi thirds. Here's an angle of negative 2 pi thirds. Okay? Those are coterminal. You can see that. Okay? Again, if I were to take negative 2 pi thirds, if I want something that's coterminal with that, I could add a multiple of 2 pi to that. So if I add 2 pi, I get 4 pi thirds. Okay? What if I did this? What would that represent? Here's negative 2 pi thirds right here. What would this represent? Keep going around the circle in the negative direction again, right? So go all the way around again. So if I were to put those together, again, fractions here, this is going to be negative 2 pi thirds and then minus 6 pi thirds. So that would be negative 8 pi thirds. So again, this one, and this one, those are all coterminal angles. 2 of them happen to be negative, 1 of them happens to be positive. They ask you to do a couple things like that on the assignment. Any questions? Okay, raise your hand if you've seen this before. This is pretty familiar. Okay, raise your hand if you haven't seen this at all and this is brand new. Okay, so we're about half and half. Okay, all right. So let's talk about complementary angles. Can anybody remind us what a complementary angle is? They add up to 90. Complementary angles add up to 90, and supplementary angles add up to 180. Okay? Now, if we were talking in radians, we'd say complementary, we'd say they add to be, not 90. They add up to be pi halves, and supplementary add to be pi. Now, if I ask this question in degrees, usually this isn't very hard. If I say, what's the complement of 10 degrees? What's the complement of 10 degrees? 80 degrees, right? How do you get that? Okay, we'll do 90 minus whatever that angle was that they gave us. Okay, so if I want the complement of 10 degrees, I do 90 minus 10. Okay, what if I wanted the complement of pi thirds? What's that? Very good. What's the equivalent in radians for 90 degrees? We do pi halves minus whatever that angle is. So we do pi halves minus pi thirds. Again, this is where you really need to practice your fractions. We'd have to get a common denominator. So we'd use 6 here. This is 3 pi 6 minus, this is going to be 2 pi 6. So the answer is pi 6. So the complement of pi thirds is pi 6. That's 60 degrees. What's pi 6th again? A sixth of the top half of the circle. Top half of the circle would be 180 degrees. That's 30 degrees. Okay? Again, you need to work with those a lot so that you can recognize those. So if this allows you to find the complement, let's talk about how you'd find the supplement. Okay, if we do pi halves minus the angle to find the complement, what would we do to find the supplement? Well, let's see. What if I came up here and asked this again? So I'm going to change the instructions here. What if I change this to supplement? What? Okay. Now we're on track. What's the supplement of 10 degrees? 170. Okay. So if you want to find the supplement, only one L. If you want to find the supplement, it would be 180 degrees minus whatever the angle is, or because they want us to work in radians and we've got to get familiar with that, what's the radian equivalent for 180 degrees? Pi. So we're going to do pi minus alpha. Okay? So that's how you find the supplement. Okay? So in this problem right here, it says find the complement and the supplement of each one of these angles. So to find the complement, you just take pi halves and subtract that angle. There's the answer here. To find the supplement, you take pi and subtract that angle. There's the answer there. Again, they're just doing fraction arithmetic here. And then because this angle, 4 pi fifths, think about where 4 pi fifths would be. This is the fraction of the top half of the circle. This whole thing is pi. This is 4/5 of that. So 4/5 of that would be about right here. It's already bigger than 90 degrees. It's already bigger than pi halves, so there's no complement. And in order to find the supplement, again, you're going to take pi and you're going to subtract whatever that angle is, and we get this right here. So stop and think about why this should make sense. If the whole thing is 1 pi and I take off 4 pi fifths, I'd be left with 1 pi fifth, because that would make this whole top of the circle divided into 5 equal pieces. I've used 4 of them in this angle right here. That leaves only 1 of them for the rest of the top half of the circle to make the supplement. Does that make sense? Okay. All right. There's degree measure. Okay, and I think you're familiar enough with that we don't have to worry about that too much. These are the angles that you're going to have to be aware of. Okay, and you don't have to know them all today, but next week we're really going to hit this hard, and we're going to really solidify all those measurements around the circle, what they are in radians, what they are in degrees, and make sure we can convert fairly easily. Okay, the next page they go through what we talked about yesterday. Okay, so here's our conversion factor right there, and this is what we multiply by if we want to cancel off degrees and change to radians. You can tell that because the degrees are on the bottom. And this is what we use if we want to cancel off the radians. Again, you can tell that because the radians are on the bottom, the degrees would be left on top, and that would be the unit that we're trying to convert to. Okay? So, similar type of picture right here. Again, all the way around the circle is 2 pi or 360 degrees. Top half of the circle is pi radians, or that's going to be 180 degrees. Pi halves is 90 degrees. Pi thirds is 60 degrees. 1/3 of the top half of the circle, 1/3 of 180 degrees is 60 degrees. Pi fourths, 1/4 of the top half of the circle, so that's going to be 45 degrees. And if you divide the top half of the circle into 6 equal pieces, okay, 1/6 of the top half is going to be 30 degrees, or we call that pi sixth. Okay? Again, these are going to come up over and over and over again. We want to make sure that we've got these down. It goes through several conversions from degrees to radians and radians to degrees. Okay? Most of these are fairly nice angles. You can tell that that one's not very much that way. And let's see. I wanted to make sure we did this. Okay. We'll do that right now. So again, just to emphasize, this would be 0 radians. This is pi halves. This is pi. 3 pi halves. And if we go all the way around the circle again, we get 2 pi. Okay, you should be familiar with roughly what the decimal equivalent of that is. Again, 1.57, 3.14, 6.28 all the way around the circle, and this is 4.7. I think it's 4.71. Okay, if you type 3 times pi divided by 2 into your calculator, I think you get 4.71. Anybody want to double check me on that? Maybe, maybe not. 4.71. Good. Okay. See this one right here? That says 2 radians. If this is 0, and this is 1.57, and this is 3.14, 2 radians ought to be about right here. A little bit past this one right here, not quite close to this pi mark over there. Okay, this says it's 114.59, and that looks pretty good because that would be 90 degrees. Okay, any questions there? Okay, if hopefully you're sitting next to somebody with a book, because we're going to take a look at some problems from the textbook. And some of these are on your assignment. Let's take a look at problem number 1. Problem number 1 says, estimate the angle to the nearest 1/2 of a radian. If this is 0, and this is 1.57 radians, and this is 3.14 radians, roughly, somebody, did I hear a guess? Just a decimal radian, not even with a pi in it. I'll take 1.9. That looks pretty good, doesn't it? What about this one? Start right here in standard position. We're not all the way around the circle. We're not at 6.28 radians. We're not at 4.71 radians. We're not at 2 pi radians. We're not at 3 pi halves radians. Okay? Roughly what would this be? Somewhere between 4.7 and 6.28. About 5? Sounds good to me. It just says come within 1/2 a radian. They want you to get used to the decimal approximations for radians. Okay? Okay, let's look ahead here. Let's look at number 9. Some of these problems, again, it's just familiarity. Okay, hopefully these are pretty easy. It says determine the quadrant in which each angle lies. So on number 9, negative pi twelfths. So stop and think about what that would look like. Negative pi twelfths. First of all, we're not going in the counterclockwise direction. We're going in the clockwise direction. Okay? And if it helps, put a 1 right there. 1/12 of pi. Negative pi would be going a half circle in the clockwise direction, right? We're going to go what fraction of that? 1/12. We're going to be about right there, a tiny little sliver. It's actually about 15 degrees. So what quadrant is the answer? Just quadrant 4. It's just where the terminal side lies. Now, if you can visualize what that would be, just write down the answer. Let's take a look at this one right here. Negative 11 pi ninths. Negative 11 pi ninths. Seems a little weird. We got this fraction. We got pi floating around. First of all, we're going in a negative direction, right? If it's helpful, think of it this way. Just like we put the 1 right here, think of what fraction this would be. Okay? 9 goes in here 1 time. So this is a negative pi minus, how many were left over? 2 pi ninths. So negative pi would be here, and then another 2/9 of pi. Remember, pi is a half circle. So we're doing 2/9 of a half circle. That's not even a half of a half circle. So that's going to be about right here. What quadrant? Quadrant 2. Now, if you struggled with this at all, what could we do with this right here to make it a measurement system that we're a little more familiar with? Convert it to degrees. Let's go ahead and do that. Negative 11 pi ninths. If I change that to degrees, what goes on the bottom? Pi. Pi radians, so those can cancel. And then I've got 180 degrees right here. So those are going to cancel. Negative 11 times 180 divided by 9. Well, wait just a second. I can cancel those. That's going to be 20. So this is negative 220 degrees. We're going to go in the negative direction. Everybody knows a half circle is 180 degrees and a little bit more, 40 more degrees here. So this little sliver right here would be another 40 degrees. Does that put us in quadrant 2? Absolutely. Okay? So it would be really nice if you got familiar with radians, but if you have to just double check yourself by converting into degrees, go ahead and do that. Okay? Take a look at number 15. There's not a lot of work here other than the mental work that goes into, my gosh, how do I draw that? Because it just says sketch the angle in standard position. So let's do this one right here. In standard position, I need 11 pi 6. So again, if you have to, this goes in here once, and then 5 left over. That's a half a circle in the positive direction, plus another 5/6 of a half a circle. So there's pi, there's another 5 pi 6, so it puts us right here. That would be 11 pi 6. Any questions? Easy enough? Okay, would you draw this one? Draw what 7 pi would look like. Remember, I said I like to think in terms of half circles, because that's what pi is. That's kind of our equal measurement there. Check with your neighbors, see what they wrote. If you had to describe how you find this angle, what would you say? I know some of you got it right. Raymond, you're brave enough to answer. Uh-huh. 6 pi would be how many times around the circle? 3 times. So we're going to go 1, 2, 3, 4, 5, 6 half circles, or 3 full revolutions, and then what? Just another half. So we're going to end up right here. So this is what it would look like. It's this angle right here. Okay? It's going to start in standard position. Okay? It's going to have the terminal side on the negative side of the x-axis. Okay? So that's really all you draw. Okay? All right. Let's see. Look at number 18. It says, determine 2 coterminal angles, one positive and one negative for each one, and then give your answer in radians. So on number 18, and we'll just do this one right here, we've got 7 pi 6. So again, that's 1 full pi plus another 6th. So one way I can figure out a positive coterminal angle is I can take that and I can add 2 pi. That's going to give me one answer. So again, I've got to do a little bit of fraction arithmetic here. So I've got to get that in terms of 6. So that's 7 pi 6 plus 12 pi 6. So that's going to be 19 pi 6. That would be coterminal. That would be going around the circle again in the counterclockwise direction, in the positive direction. What's another way that I can get another one that's coterminal but would be negative? Yeah. So we're just going to take that and we're going to subtract 2 pi. Now, notice if you already did this arithmetic right here, all we have to do here is 7 pi 6 minus 12 pi 6. And what do we end up with? Negative 5 pi 6. So again, coterminal, coterminal, coterminal. Okay, all 3 of those end in exactly the same place, but they've got different measurements. Okay? All right, skip ahead to number 23. Now let's do 21. Let's do number one of, or A of 21 and A of 23. So let's do these two right here. Okay. It says, if possible, find the complement and the supplement. So think about pi thirds. Can you find a complement for that? You can, because that angle is 60 degrees. It's less than 90 degrees, right? Okay. So in order to write this down, we're going to write this. Remember, to find the complement, you do pi halves minus the angle. My gosh, didn't we already do this? We figured that one out. Okay. Answer is pi 6. How would we find the supplement? Pi minus pi thirds. Okay. If I take, and let's say it this way, if I take 1 pi and I subtract 1/3 of pi, what would be left? 2/3 of pi. Or 2 pi thirds is the way we normally say it. Okay, let's take a look at this one right here. Will that one have a complement? Think of where 3 pi fourths would be. 3 pi fourths is in quadrant 2. It's already bigger than 90 degrees. It's already bigger than pi half, so no complement. Would it have a supplement? Yes, it would. Take a look at number 23. We'll do that one. This is a weird one, but it's actually pretty cool because there's hardly any work to do. Okay, where would that angle be if that's in radians? What quadrant? 1 radian was about right there. It was about 57 degrees, wasn't it? You figured that out yesterday? Okay. How do you figure out the complement of that? Pi halves, subtract 1. And you can leave it like that. That's the cool part. So the complement, supplement. This is the complement. How would I find the supplement of 1? Pi minus 1. That's it. Okay? It's literally that easy. Okay? All right. On these right here, these are the instructions. What does this mean you do? What's the word? Convert. Convert from degrees into radians. Go ahead and flip the page over. Convert from degrees to radians here. You're going to need a calculator on these because these are going to be kind of ugly numbers. But these right here, do those angles look familiar for the most part? You should be able to do some cancellation by hand and figure out what those are. Okay? And let's see. So we have any problem with these? It's just convert, right? What are we going to multiply by? This is going to be 180 degrees over pi. And up here on these other two, it's going to be pi over 180 degrees. Remember, the degrees on the bottom, because you want to cancel the degrees, turn it into radians. Pi on the bottom, pi radians on the bottom, because you want to cancel off the radians. Okay? Let's see. Let's look at number 63, part B. And then we're nearly done. Okay, would you go ahead and answer that one right there? If you can answer that, then you're in good shape on those parts of the assignment. How do I find a positive one that's coterminal with that? Add 360. Okay, and how do I find another one that's negative that's coterminal with that? Subtract 360. Okay, just like we were doing with radians before, now you can do it with degrees. Okay, and I think the author of this textbook arranged it with doing the radians first, then the degrees to kind of force you to get used to those. Okay, however you need to do it to make sense is fine. If you need to do the degree stuff first and then go back and do the radians, that's okay, but you have got to get used to radians. All right? Okay, let's flip ahead to problem number 80 and 82. Okay, look at the instructions there. It says find the angle in radians. Okay, first of all, is this positive or negative right here? Positive. Positive or negative? Positive, negative. Okay, so at least you know what the sign is on the answer. Okay, let's do number 80. What is that angle in radians if this arc right here is 29 and this radius is 10? Any ideas? Raise your hand if you think you might know. Okay, we've got about 5 or 6 people. That's great. Let's see if everybody can get this. Remember what a radian is. Okay, what is a radian really? Why did they call it a radian in the first place? Radius, right? So it's how many radiuses or fractions of radiuses you went around the outside of the circle. So if this is 29, how many radiuses would that be? Almost 3, right? In fact, exactly 29 divided by 10, that's how many radiuses it would be. It would be 2.9 radiuses, wouldn't it? Okay, now stop and think about this. That seems a little bit weird that somebody would do it that way, but remember those circles that we did yesterday where everybody had a different size circle and all the angles that we've drawn today? Didn't we say this would be 0 radians? And didn't we say straight up and down at 90 degrees this would be about 1.57 radians? What did we say this would be straight across? 3.14. And what did we come up with here? 2.9. Isn't that about where we'd expect it to be? Okay. Any questions? Okay. I'm going to hand out the assignment then.